Hi, in this video, we're going to look at the timing of different methods pertaining to lists and dictionaries. I think mainly it's going to be lists, but we'll take a look here. The first one we're going to do is looking at pop zero and pop end. And you may think, well, what's the difference between the two? Just one takes it off the top and one takes it off the bottom. Well, let's go ahead and put in the code, and then we'll look at and talk about the comparison between the two. So we're going to start off here with importing timeit. Be a way to be able to track the time. Create a variable called pop0, which is going to be equal to timeit.timer, passing in x.pop0, and then from underline main underline space import x. Okay. Then we're going to have pop end. It's going to be equal to timeit.timer x.pop from underline main underline space import x. Okay. Now this doesn't work when I do a main function, and I think it has to do something with this from main thing here. So we're just going to do it this way so we can get this to work here. So x is going to be equal to a list in the range. And let me count these here. 3, 4, 5, 6. So it's 2, 0, 0, 0, 0, 0, 0. Okay. So that is 2 million. Okay. You have to make it large enough so it has something to measure time-wise. And then we're going to do a pop 0 dot timeit number equals 1000. We're going to do an x equals list range. Do the same thing. And then print pop end dot timeit number equals 1000. Okay. So I'll get this saved. And I'll have to navigate to where I'm saving it here. I'm going to call this pop test 1.py. Okay, so let's run this and see what happens. There we go. The first one took 2.74 seconds. The second one took 9.66 e to the minus 5. So this was really fast here, not so fast there. Let's take a look at this. And the reason for that is, if you think about it, when you do a pop end, which was the second one that was really fast, it doesn't take any time because it's just taking it off the end. It has no effect on anything else in the list. But when you do a pop 0, it takes it off the front end. And when it takes it off the front end, then that means everything below it has to shift up one in order to fill that spot. So if you have 2 million items in the list, 1, 2, 3, 4, 5, 2 million items in the list, then it's got to do 2 million shifts, or 1,999,999 because you popped one off. It's got to shift all those up. So that takes some time to do that. Okay? That's the reason for that. So let's do another one here. And I think that I can use the same part up here at the top. And then I'm going to change all this down here. So make this a print percent 15s space percent 15s end quote. Oh, need a quote on that. And then we're going to have percent and then parentheses pop 0 and pop parentheses and parentheses for the pop at the end. And take that D out of there. Okay, then we're going to run through a for loop. For I in range 1 million, comma, 1, 2, 3, 4, 5, 6, yeah. 1, 2, 3, 4, 5, 6, 1, comma, 1, 1, 2, 3, 4, 5, 6. Okay. We're going to do an x equals list range I, oops, and then pz is going to be equal to pop 0 dot time it, and then number equals 1000. Then we're going to do an x equals list range I, pt equals pop n dot time it, number equals 1000. We're going to print percent 15 dot f 5f and then percent 15 dot 5f percent and then in parentheses pz comma pt. Okay, so I'll save this one, and I'll save this one, change the 1 here to a 2, and then let's see what happens with this one. Okay, I'm going to stop this because I got a little error in there. Okay, this should be 15.5f and then percent 15.5f. So let's try this again. So the first time through we get on the first one is 1.5, second one is 2.8, 3.9. Notice the other one is pretty close to being the same on each one. This one keeps increasing a little bit each time. And as we go further into it, it's going to keep increasing on this. With the pop 0, the more we put in there, the longer it's going to take to run, where the pop stays constant. Although it'll go a couple more times and it'll just break out of it. But to just give you an idea of what's going on here, that as you add more items to the list, pop 0 takes a lot longer. So that's why you need to be able to analyze what you're doing to make sure that you're getting the best big O notation that you can on them. Do one more. There we go. I'm going to go ahead and break out of this. Kind of that gives you the idea. So just another example of why it's important to understand how big O works and to figure out the performance of your algorithms in there. So I hope this helps you out with this, and I will see you in the next video. Bye.